Hey kids, today we're going to go through the proof of point two circle with two interior chords. What we're going to try and do today is we're going to prove that AE times EC is going to equal BE times DE. Now, the last time we saw this idea was when we had something like this, where we had AE over BE, and that was going to equal, I'll just write it as DE over CE. Now, this idea was when we wanted to prove similar triangles from earlier. So what we want to do is I want to get some similar triangles here, show that this ratio is true, and then get it to say this statement up here, okay? So in order to do that, we're going to need some triangles. So what I want to do is I want to add in some triangles, and then we will go through the actual proof. So here is the actual proof. So one, we are given the picture, and that is going to be given. And then what we did is we draw in AD and BC. Okay. Now going through here, now I have two triangles. And what I got to remember is, how can I prove these triangles? Well, similar. So in order to go through this, I know I have some kind of angles here that are going to be congruent. In order to make our life easier, let's put some numbers there. So let's say that angle 1 is congruent to angle 2, and remember that is vertical angles are congruent, okay? Or you could use the vertical angle theorem, depending on what you want to write. Just don't write vertical angles, because I want to say that either the vertical angles are congruent or the vertical angle theorem. So that is one pair of angles that we know are congruent. And the next one that we want to do is I need another angle. And so what I need to do is reference some of these angles to the circle. So if I take a look at this angle right here, okay, so that angle right there, that cuts this arc, okay. Also, this angle over here cuts the same arc, okay. And if you need to see in those, here is this angle right here, and you can see that it cuts the arc. Also, here is this angle right here, and you can see that it cuts the arc. So I know then that these two angles are going to be congruent. So that's what I want to say, is that step 3, I can say that angle D is congruent to angle C. And now we need a reason. The reason just isn't inscribed angles, but it's going to be inscribed angles that intersect the same arc are congruent. Okay. So I know that I now have two angles congruent. So if I have two angles congruent, what I get is I get triangle EAD is similar to triangle EBC. And the reason is angle similarity. So finally, now that I have some triangles that are similar, I can set up this ratio. So I can go AE over BE is equal to DE over CE. And the reason is because the triangles are similar, the sides are proportional, which we can say is definition of similar triangles. And then finally, I can get to this last part. AE times CE is going to equal BE times DE. And if I look at that, we are just cross multiplying. So that is going to be cross multiply. And that is done. Okay. And we're just going through and remembering some things from first semester about similar triangles. Similar triangles are proven by angle similarity. And then I can set up this proportion, which leads to this final statement, which is what I wanted to prove. Okay, so this is the proof that you are going to have to turn in through Kami. And if you notice, we are taking this idea of point to circle AB times point to circle AD, again, point to circle and point to circle. So what we want to do is we want to find all of the things we did in our last proof, or most of them, as far as similar triangles, and try and prove that we have some similar triangles. Now, if you notice, we drew in these two things for you, and there's a lot of triangles here. Okay? Now, I'm going to give you a hint of what you're looking for. You are looking for overlapping triangles to do this proof. Okay, so what you need to do is follow through this proof, fill it out on Kami, and then submit it to your teacher. If you have any questions,